All right, buckle up, hang tight. We are talking about simplifying radical expressions here in Algebra 1. It's about to get crazy. So, a radical expression is an expression that contains a radical. For example, a square root. Okay, there's also other types of roots. But we're going to be dealing with square roots. The radicand, write this down, that is the expression underneath the square root, underneath the radical sign. It's called the radicand. For example, in this right here, the expression underneath, right? The expression underneath is the discriminant. The discriminant is the radicand. All right, a radical is in simplest form if the following are true. 1. No radicands have perfect square factors other than 1. Next, no radicands contain fractions, so you can't have something like this. Okay, that's not in simplest form. No fraction underneath the square root. And next, no radicals appear in the denominator of a fraction, so you can't have this. No good. That is not in simplest form. All right, so no fractions under the radical sign, no fractions in the denominator, and no perfect square factors other than 1. We'll look at this one a little more. So, product properties of square roots. If you multiply two square roots, you could put both of those factors underneath the same radical sign. Okay, simplifying. So, 80, I can break 80 down into its prime factors. Okay, for example, 80 is 4 times 4 times 5. Okay, 16 times 5. Now, 4 times 4 is a square, right? 4 times 4 is 4 squared. So, we could look at it as 16 and pull out 16. And I can get a square root of 16. The square root of 16 is 4. And so I get 4 times radical 5, or we just put those together, 4 radical 5. Multiplying square roots. Remember, if we have two square roots and we're multiplying them, we can put both factors underneath the same square root. So that's 2 times 14, so it's radical 28. Now I can factor out 28 and see, are there any perfect squares underneath here? Well, here's your list of perfect squares to 100, and 4 is a perfect square, so I can pull that out. Find the square root of 4. That is 2. 2 times radical 7 can be written as just 2 radical 7. Simplifying square roots with variables works much the same way. X squared, the square root cancels out the square, so that's x. Here we have 90, x to the third, y to the fourth, z to the fifth. We're going to break this down into perfect square factors. So 90 is 9 times 10, there's a perfect square. X to the third is also x squared times x. X to the fourth is y to the fourth is y squared times y squared. Z to the fifth can be broken down in z squared times z. Now I can pull out all the perfect squares. So I can pull out the 9, square root of that is 3. Can pull out the x squared, square root of that is x. Pull out the y squared, pull out the next y squared, the z squared, and then what that leaves me with underneath the radical is 10xz. And then I'll simplify this. Y times y is y squared. And this is my final expression. Okay, quotient property of square roots. Same thing that we had for multiplication, where we can write them both underneath the same radical sign, works for division too. When you're dividing, you can write them both underneath the radical, or if they are both underneath the radical, you can split that up and say radical a over b is the same as radical a over radical b. So, here we have a multiple choice. If you want to look in your book, which one is equivalent to this? Well, we are going to simplify this expression. And here we have 13 over 15. Now, in order to simplify this, remember, we can't have a fraction under the radical sign. We also can't have a radical expression in the denominator. So what we're going to use here is a 1 fraction, something divided by itself. Okay, I can always multiply anything by 1. This here is a 1 fraction, right? This is just like I'm multiplying this times 1. Okay, so if you multiply 15, square root of 15 times square root of 15, you're going to get 225, or these cancel out because we end up with 15. Now, in the numerator, 35 times 15 gives me 525. We will factor this out and find the perfect square also here, and we can pull that out. Remember to simplify. Simplify your fractions, otherwise the whole thing is not simplified. And finally, we have this option. So if you're following along with your book, that is option B. Now, they have given you some other options that are equivalent, but they're not in simplest form. All right, conjugates. If you have something plus something, the conjugate is that same something minus that something. So we could have this as A plus B and A minus B. You might recognize this from the last chapter, using binomials, difference of squares. Okay, same thing works with numbers. 3 minus 2 radical 7 or 3 plus 2 radical 7. Now we're going to use that property of the difference of squares to rationalize. That means to get the radical out of the denominator. So if you remember the difference of squares, we have a minus b times a plus b gives me a squared minus b squared. So each of these factors is going to be squared. Each of the terms is going to be squared. So if I expand this by the opposite sign, by the conjugate, then we will have the factors for a difference of squares. So I'm going to expand this by the conjugate, and what that's going to give me is the square of each of these terms. So on top, I'll do 3 times 5 and 3 times radical 2. Distributive property, basically. Remember, this is like parentheses here. Okay, so we've got 2 binomials that we're multiplying. Then on the bottom, we have 5 squared minus 2 times radical 2 times radical 2, which is radical 4. And radical 4, we can square root that, and that's just 2. And now I've gotten rid of the radical in the denominator. Now all I have to do is simplify. Okay, that's 23 right there. I've simplified, I've rationalized this, gotten rid of the radical out of the denominator. And that is it, ladies and gentlemen. I know this is a lot to digest. Make sure you've taken good notes. Go back over, check your notes, read through your notes, highlight, use lots of colors. That's all the fun we're going to have today. And remember to like and subscribe if you haven't already. And hit that notification bell, become part of the notification squad.